Algebra 2, Chapter 16.1, Properties of Logarithms. Essential question, what are the properties of logarithms? And that's the main topic of what we're going to go over here. I want to first talk about what a logarithm is. And what a logarithm is, it's a form of an exponent. So you might see something written like this: log base 3 of 81. This is a logarithm. So what a logarithm is, it's the answer to the question, what power does this number, in this case 3, need to be raised to equal this number, in this case 81. And so 3 to what power, question mark, equals 81? Well, if you can think, 3 squared is 9, 3 to the third power is 27, well, 3 to the fourth power is 81. So the answer to the question is 4, because 3 to the fourth power equals 81. So we're going to be going over properties of logarithms today. The first part is an exploration, investigating the properties of logarithms. And what we basically have here is a calculator exercise. So I'm going to get out our calculator. So the first one we have here is log 10 over e. And what log is, and here it is in the calculator, what log is, it's log base 10. So we're going to have log 10 over e, and e we find by going second and to this division sign. E is a special number. So we get 0.5657. So we go over here, 0.5657, and then ln 10. Well, ln stands for the natural log, so the ln key here is 10. And so this answer is 2.303, we'll call it. 2.303. And then log of e to the 10th power. So let's look at that. Log of e to the power of 10. There we have it, 4.343. And the last one we have here is log of 10 times e. So here we have it. Log of 10 times e. So for this, we get 1.434. And now we go to this column on the right, 1 over log e. So here we go, 1 over log e. So we get 2.303. And then 1 plus log e. 1 plus log e which is 1.434. Then 1 minus log e, we get 0.5657. And then 10 log e. For this one, we get 4.343. And so you should notice, I hope, that these numbers have similarities. These two are equivalent. I'm just going to draw the arrows. Okay, these are equivalent here. 0.4. These two are equivalent. And the last one okay, so we're going to mention those here. And so what are the equivalent expressions? Well, we have 1 minus log e is this one. ln 10, that's going to be 1 over log e. This log e to the 10th power is 10 log e. And then finally this one, log of 10e, is 1 plus log e. So these exercises demonstrate properties of logarithms. That's where we're going next. And here are the properties of logarithms. And they're kind of academic. One important one here is if you have a log of base, whatever it is, of 1, that number is 0 because any number to the power of 0 is 1. And then you have the product property of logarithms, where if you have the log of two numbers together, they are the log of that first number, or the first factor in that product, plus the second log of the second factor of that product. The quotient property, if you have logarithms, if you have a logarithm of a division, what you have, that's going to be equal to the log of the numerator minus the log of the denominator. The power property of logarithms, if you have the log of something to a power, you can take the power and move it out front. And then the change of base property, and the change of base property is very helpful because a lot of times you'll have a base that's different than ln, which is the same as log base e, or log, which is really equal to log base 10. Okay, so those are important rules, and we're going to put those into action here. Okay, given positive numbers m, n, and b is not equal, and prove the product property of logarithms. Let x equal log base b of m and y equal log base b of n. Rewrite the expressions in exponential form. Well, m is going to be equal to b to the x power, and n is equal to b to the y power. Okay, and that's rewriting these as exponentials. So log base b of mn equals the log base b of b to the x times b to the power of y. Okay, so that's one logarithmic property. Use the product of powers. That's what it is. And use the definition of logarithm here. The power property here is going to be log base b of x times y. And down here, d, use the definition of logarithm to simplify further. Well, what you're going to have is x plus y. And what this is, when you have log base b of b, it's like the base and the b cancel each other. You just have left the x plus y. Substitute in for x plus y. We have log base b of m plus log base b of n. Okay, let's go on here. And then using the properties of logarithms, there's an example worked out, and I'm not 100%. They don't really take all the simplification steps I would, but what it is, you have the difference of logarithms is going to be the same as the quotient of the first number over the second number. And then simplifying, you get to 1/3, and then what you have is you can gradually work this out to get an answer of -1. And then they show a check of the work. So I'm going to go through this one right here, which is log base 5 of 1/25 plus the log base 5 of 625. Well, what we have is the log. So what we're going to have is it's going to be, since you have a sum here, you're going to actually multiply these together, because that's just the product property of logarithms. So for that, we have log 1/25, 625 divided by 25 is 25. And so what this is going to be, that's going to be log of 25 over log of 5. And that's going to be approximately, if we work that out in the calculator, we'll get 1.398 over 0.699. But it's really simpler than that, because what happens is we can rewrite this 25 as 5 to the power of 2, and we can take this 2 out front here like this. So that's going to be equal to 2 log base 5 of 5. So what power do you have to raise 5 to equal 5? 1. So log base 5 of 5 is 1. So 2 times 1 equals 2, which is the same thing you get when you make this division here. And then you can check your work. Log base 5 of 25 is 2. We can do on our calculator. And as far as where you find that, log I will show you that. If you go to math, to number, I think it's here. No, it's not. I'm trying to look where that log base is here. Yeah, it's going to be here. There it is. Log base. So log base 5 of 25 is going to be equal to 2 because, so that's where you would find that. You can make those kind of checks in your calculator. Okay, so 25, that's going to be equal to 25. Yeah, 2, 5 squared, 5 equals 25. Check. Okay, next, your turn. Express each expression as a single logarithm. Simplify if possible. And so what you have here is you try to write this as, the thing that would be really helpful is if you could write 64 as a power of 4. So log base 4 of 4, you can write 64 equals 4 to the power of 3. So we could write this as 4 to the power of 3 to the third power here. And so what that is, that's going to be equal to log base 4 of 4 to the power of 3 times 3, or 9. And then what we can do is we can take this 9 out front. It's going to be equal to 9 log of 4 to 4, and log base 4 of 4 is 1. So our answer to this one here is 9. And then for 5, it starts out, you have a log base 8 of 18 minus log base 8 of 2. So we could combine these in a single logarithm of log base 8 of 18 over 2, and that's going to be equal to log base 8 of 9. And we can rewrite 9 as a power. Can we write log 9 as a power of 8? Well, we can use a change of base because we don't have a 10 here. So we use a change of base. So we can write this as log of 9 over log of 8. And so we can go to our calculator. Log of 9 over log of 8. And we're going to get an irrational number out of this deal here. So 1.0566. So I'll put approximately 1.0566. So that's it. Okay, this is as far as I want to go today in these in this introductory demonstration. So we're going to go on to the problem exercises, and you gradually figure that they're not too hard. It's a matter of getting the practice and getting familiar, and eventually going to go back and forth between exponents in the form of logarithms and just a regular exponent. I hope this helps. Thanks for viewing.